For the mechanical system shown in figure, write the differential equations describing the behavior of the system. That is the first part. Second part is draw the force voltage as well as force current analogous of the electrical circuit. Now, let us find the differential equations governing the behavior of the system. So here two masses are there, M1 and M2. So if we draw the free body diagram, M1, what are the forces acting on it? The forces acting on it are because of K1, B1 and M1. The displacement is towards right, that is towards right X1. Therefore, the reaction forces will act towards left. The reaction forces are because of K1, another force is because of M1, and the third one is because of B1. These are the three forces acting on it. Reaction forces because of the displacement X1. Second mass is M2. M2. On that, the displacement is towards right, that is X2. The force applied is F of T. And because of that, there are some reactions because of M2, that is Fm2. Another force is FV1. The third force is because of FV2. FV2. Because of the reaction between the mass and the surface. Another one is K2. K2. These are the forces, reaction forces acting on it. Therefore, for the first equation, Fk1 is K1, spring constant multiplied by displacement. Because of M1, the reaction force is M1 T square X1 by dt square, plus because of B1, the forces are d by dt of X1 minus X2, because the dash part is between M1 and M2 equal to 0. This is the first differential equation. The second differential equation, because of mass M2, is Fm2. That is M2 T square X2 by dt square plus K2 X2 plus P1 d by dt of X2 minus X1 plus V2 d by dt of X2 equal to F of T. This is second equation. The first part is over. Now we have to find force voltage as well as force current analogies. To find force voltage analogy, we have to replace K1, K by 1 by C1 or K2 by 1 by C2, like that. And M should be replaced by L. And B should be replaced by R, resistance R. And X by Q, charge. The applied force F of T should be replaced by V of T. Therefore, the equation, the first equation becomes replace K1 by 1 by C1. 1 by C1, X1 should be replaced by Q1 plus M1 should be replaced by L1. L1 d square by dt square of Q1 plus B1 d by dt of Q1 minus Q2 equal to 0. Similarly, the second equation, M2 should be replaced by L2. Therefore, L2 d square by dt square Q2 plus K should be replaced by C1, 1 by C2. This is K2, that's why C2 Q2 plus D1 should be replaced by R1. R1, here R1. R1 d by dt of Q2 minus Q1 plus R2 d by dt of Q2 equal to applied force F of t. That becomes V of t, applied voltage, equal to V of t. This is third equation, this is fourth equation. But we know that dq by dt equal to I. We know that dq by dt equal to I. That's why q equal to integral of I dt. By using these two relations, we can replace the above equation in terms of I. 1 by C1 integral of I1 dt plus L1 d by dt of I1 plus R1. dq by dt is I. Therefore, I1 minus I2 equal to 0. This is fifth equation. The fourth equation becomes L2 d by dt of I2 plus 1 by C2 integral of I2 dt plus R1 d by dt of Q means I2 minus I1 plus R2 I2 equal to V of t. This is sixth equation. That's all. Draw the force voltage analogy circuit. We have to draw the circuit for this. Here two currents are there, two equations are there, therefore two loops are there. This is the first loop. This is the second loop. Second loop. In the first loop, the current is I1. The second loop, the current is I2. That's all. Take the fifth equation, C1, I1. Through C1, I1 alone is flowing. That's why this is C1. L1, through L1 also only I1 is flowing. Therefore, through L1 also I1 alone is flowing. But through R1, I1 minus I2. I2 is against. That's why you have to draw. R2 is common to both loops. That's all. First equation is over. Second equation, L2. Through that only I2 is flowing. Therefore, L2 through I2 is flowing. Through C2 also through I2 only. R1 is common to I1 and I2. I2 minus I1. Yes, I2 minus I1. That is common to R1. Already we have drawn. Through R2 only I2. Therefore, we can draw here R2. And V of t is the applied voltage. It is, if it comes this side, it becomes minus. So that's why it is against the current direction. That's why we have to draw like this. It is on the other side. That's why it is against current direction. V of t. So we can put the like this, or we can put like this, V of t, without mentioning any V of t. That's all. First part of the second part is over. Now we have to obtain force current analogy. For that, we have to assume M equal to C and X is Q. and V is 1 by R. d phi by dt is d phi by dt is V. K is 1 by L. K is 1 by L. 1 by L. We have to replace K by 1 by L. That's all. If you do like this, what you will get is, consider the first equation. First equation becomes, we have to replace M by C, K by 1 by L. Therefore, 1 by L1, 1 by L1, phi 1 plus M by C, C1, T square phi 1 by dt, plus V1 should be replaced by 1 by R1, d by dt of phi 1 minus phi 2 equal to 0. This is seventh equation. Now second equation, again replace second equation by M by C. Therefore, C2 d square phi 2 by dt square, C2 d square phi 2 by dt square, plus K. K should be replaced by 1 by L. 1 by L2 phi 2, plus B1 should be replaced by 1 by R1 d by dt of phi 2 minus phi 1, plus 1 by R2 d by dt of phi 2 equal to I of t, because current source. This is the eighth equation. That's all. Now we have to draw the circuit for this. Consider the seventh equation. Now we know that d phi by dt equal to rate of change of flux equal to voltage, or phi equal to integral of V dt. These two relations we know. By using this, if you replace the seventh equation by voltage, what you will get is 1 by L1. The first expression, 1 by L1, phi 1. Phi 1 is integral of V1. Integral of V1 dt plus integral of V1 dt. Second, C1 d square phi 1 by dt. d phi by dt is V. Therefore, C1 d V1 by dt plus 1 by R1. d phi by dt is what? V1. Therefore, 1 by R1 V1 minus V2 equal to 0. That's all. This is ninth equation. This is the required current, force current analogy. So, eighth equation becomes C2 d phi by dt equal to V. Therefore, d square becomes d V2 by dt plus 1 by L2 phi 2 is integral of V2 dt plus 1 by R1 V2 minus V1 plus 1 by R2 d phi by dt equal to phi 2. d phi by dt, that is V2 equal to I of t. This is 10th equation. Now we have to draw the circuit for this. Here, this is for nodal equation. How many nodal voltages are there? Two nodal voltages are there. One is V1, another one is V2. Therefore, V1 is one voltage, another voltage is V2. For a nodal equation, always there will be a reference. This is the reference. Reference. V reference. Now we have to draw V1. V1 means between V1 and reference. L1. L1 is between V1 and reference. This is over. This next one is C1. C1 also between V1 and reference. C1 also between V1 and reference. The third one is R1, that is between V1 and V2. Therefore, we have to draw R1 like this. Between V1 and V2. V1 and V2, V reference. Then C2 is between V2 and reference. C2 is between V2 and reference. L2 is between V2 and reference. L2 is between V2 and reference. R1 is again between V2 and V1. Already we have drawn. V2 is between, the R2 is between V2 and reference. V2 and reference. That's all. One more thing is the current source. The current source is between V2 and reference. The current source is between V2 and reference. For this node only, we wrote this equation. That's why it is here only. The current source I of t is between this node and reference. That's all. This is the force current analogy. That's all. That's all.